Hello everyone, welcome to my presentation. My name is Naushad and my co-author is Samantha Rajapaksa. This is the paper ID 159, an ontology-driven question answering system for computer network module. Introduction. Question answering is a branch of AI within the natural language processing and information retrieval field. It building a system that answer questions that are posted in natural languages by the users. Then we look at some background studies. An ontology-driven question answering system for legal document, which is published in 2019 in India. They have developed ontology-driven question answering for motor vehicle department. It defines a set of offenses and related penalties. They have used semantic role labeling to identify the roles of each word in the offense. Also, they have used ontology to create use as the medium for question answering. Finally, they have developed a system which is extracted domain-specific terms with minimum human intervention. Another research paper called Design of Ontology-Based Question Answering System for Incomplete Sentences, which is published in 2019 in Indonesia. They have designed an ontology-based question answering system that's capable for dealing incomplete question sentence. They have used two approaches. One is design an ontology that used keyword property to find the question objective. The second one, design an architecture that transforms the question in natural language into instruction that can be understood by the machines. Then the test case were conducted on 3 groups of question sentences. One complete question sentence and incomplete question sentence also can be tested, and keywords also tested. There is another research paper, a domain-specific ontology-based question answering system, which is published in 2016. They have aimed to develop an automatic query generation for natural language questions, thereby developing a domain-specific natural language question answering system for ontology. The accuracy of the system is improved by using the DBpedia ontology for extracting some sort of information about the domain. They focus on the domain of news events of new appointments in various organizations. Finally, they have developed a QAS system for the domain of news events of new appointments in various organizations. The other one, an agriculture domain question answering system using the ontologies, which is also published in 2019. They have developed a QA system on agriculture domain. They have used techniques in natural language processing and semantic web technologies. They have developed a prototype in Java, and the basic information about agriculture is collected and fetched. The questions are tested by the system in many forms. However, in every time it returns the same answer. This proposed system aims to design and develop a question answering system for computer network module with the help of ontology, and also to provide precise answer for user question quickly. This project also aims to ensure that the answers provided by the system are identical to the answers the user is looking for. This research project try to find out the following research questions answer. How the proposed QA model helps IT students to get the exact answer to their user queries. What are the real benefits of this proposed QA system, and how this particular QA system differs from the existing QA system. Then we need to look at the architecture of the QA systems. This is the general architecture of any question answering system. When enter the question, it goes through this kind of pipeline, like question analysis, document analysis and retrieval, and answer analysis. Finally, it returns the answer. And this is the ontology-based architecture, where each component of the question answering system is linked to ontology. And this diagram shows our proposed architecture, where user enter the question through the user interface and get the answer. And we have used ontology and the web-based to get the answer, and other components remain same as the previous system. Then the QA system process, in general, they have three components: question analysis, document processing, and answer processing. Question processing has subcomponents of tokenization, stop word removal, type of the question needs to be identified, and stemming, and part of speech tagging. Under the document processing, we need to establish the ontology for RDF store and ontological dictionary. Finally, we have to maintain the knowledge base. And the answer processing, we need to retrieve the answer from the source that we have developed for this particular question answering system. This table shows how the question analysis phase carried out. Question words whose mainly focus on the person, whereas the where it asking in or what place or position, so it returns location. This Python program shows how question analysis will take place in question answering system development process. This particular research have minor innovation or novelty. That is, the user have multiple options for getting the answer from the ontology or from the web-based system. And this existing knowledge is going to apply in new domain. It is ICT subject, computer networking. First, we have used a web-based QA system. Here we used Google and Wikipedia search engines to get the answer. We are not get all the answers, but using the filters we use, first three results are returned as an answer. When we enter the question using this web interface, we get the answer. Then we have to develop an ontology-based question answering system. To do that, we need a data set. So computer network module information or the data can be obtained from the website of the National Institute of Education by accessing their official website www.nie.lk and the following toolings. We have used a couple of packages and tools to build the ontology. Protege 5.0 software we have used to create the ontology, and Python is the programming languages, and some Python packages like NLTK. It is very useful to do the pre-processing uh, of the question, and tkinter. It is a standard GUI library for Python, and already too, it is a package for ontology-oriented programming in Python, and Flask to build a web application like that. Then we need to build the ontology. So there are classes, the concept of the ontology and type of the ontology. Then we have to build or we have to create individuals. Individuals are the specific instances of the concept, and the concept can be described more clearly by the set of common attributes that can be called properties. There are two properties, data property and object property, that can be discussed in the following slides. And the relation, it describes the interaction between concept or concept properties. For an example, subclass of or is an exit. This is the class hierarchy of the proposed system. A computer network is the subclass of thing, and protocol, IP address, basic, reference model, topologies, security concern, and network devices. Those are the subclasses of the computer network. And this picture shows the complete class hierarchy. For an example, a reference model, it has another two subclasses called TCP/IP model and OSI reference model. Each reference model has its subclasses. For an example, OSI reference model has 7 layers, and these 7 layers are the subset of or subclass of the OSI model. Then the object property is used to connect two classes or two instances. For an example, IP address and network devices are two classes in this class diagram. So these two classes are connected using assign to object property. Like that, data property is used to create a relation to a class with literal. Here we have to define the domain and the range. Now we have both system called web-based system and ontology-based QA system. So we need to compare the performance between these two question answering system. For that, we need to have some sort of performance parameters, accuracy, precision, recall, and F measures. Accuracy is measured as a percentage, whereas the other three components lies in between 0 and 1. 0 is the minimum value, whereas the 1 is the high value. The optimum value can be greater than 0.7. In both systems, we have tested with 45 sample questions. Same 45 questions are fed into both systems, and the answers are recorded. Web-based QA system results are shown in this table, whereas ontology-based QA system results shown in this table. These results can be computed the performance indicators based on the results obtained and compare these two systems according to that results. Accuracy 38% in web-based QA system, whereas 87% of accuracy for ontology-based QA system, and other three factors having 0.93 for ontology-based QA system and web-based system have lower performance indicators compared to the ontology-based system. These figures can be graphically shown in this diagram. Finally, the conclusion. Using the results, we can come to conclusion like ontology-based QA system returns better responses to the user queries than the web-based system. Also, the ontology-based question answering systems giving quick response compared to the web-based system, because web-based system need to search a lot of web pages, unlike the ontology-based system. And the end user can easily recognize and identify the difference between both system answers. These are some recommendations. This ontology can be extended to accommodate other computer modules like operating system, database management system, and data communication, and so on. So the user can get more subject to test and get the answers. Also, the ontology-based QA system can be implemented in other local languages like Tamil or Sinhala language. And also, this question answering model can be implemented or incorporated with some machine language algorithm to improve its efficiency and usage across multiple dynamic knowledge bases. These are some references that we have gone through to do this research and prepare this presentation slides. Thank you. Thank you for listening.